Hey everyone, I hope you all are safe and doing good. From this lecture, we are going to start Java collection framework. So, first in this lecture, this is the introduction type of lecture. So, in this lecture, we will see basically why we need Java collection framework. So, first we'll see like what is a framework, what are collection, what is collection framework, and why we need collection framework. And then we'll see the hierarchy of collection framework. Okay, so this is kind of introductory video. So if I say what is a framework? If I ask you what is a framework, it's like in simple general meaning of in English, simple meaning of framework is it's like a basic structure which gives some kind of shape to something. It's a framework. Like we can say, have you ever seen that brick making traditional brick making system? So they are supposed to make bricks, and every brick is having certain height, certain length, and width means dimension. So if suppose they are going to make 10, or you can say 10 bricks. So they are going to measure first the length, the height and width, whatever is needed. And according to that, they are going to make that brick. Right. Now, suppose you are going to make, suppose 1,000 bricks, thousands of bricks. So it's not like that for every brick you are going to measure the dimension like the length, the height and the width of the that brick. No, it would be like tedious task, and definitely having errors. I mean, in terms of programming, if I say, it's like all the thousand bricks are of not having same dimension. That is for sure. So what is that? Maybe you have seen that one box kind of thing. That is kind of framework. They have this kind of thing, that hollow kind of thing, and they just put that dough. I mean, whatever they make from that mud and all to make that brick into this box, into this container, and that's it. So this one container is of the required dimension of that brick. So with this, they can make thousands of brick, and every brick is having like same dimension and easily and very quickly. It's time saving. So it's kind of, you can say that is a nothing but framework. It's a structure that gives the shape to that particular thing, the bricks, right? So that's exactly the framework is here in the programming also. Okay, but see, maybe you have heard about frameworks many times, like Spring is a framework, React, Django, Angular. There are so many frameworks available. But this Java collection framework is not same as those frameworks. Don't get confused in these terms, because we are calling this also framework, Java collection framework. Spring is also a framework. React is a framework. If you are aware about Python, then in there we have Django is a framework. Angular is a framework. In different languages, there are so many frameworks. But those are different. This Java collection framework is different from those. It is more of library like framework. Now, what is this library like framework? See, libraries, what are libraries? We know, I have told you many times, Java has a rich set of like those built in libraries. There are so many, it's like in libraries, there are so many already written classes, and within those, we are having so many methods. We can directly use those methods and classes in our program, and you don't have to write the code from scratch. Like we have math. From there, we can use many, like square root is a method here. So we can directly use the square root and something like this to find a square root of a number, power of a number. Or in the previous section, we have discussed file handling. So there, for file handling also, there are so many classes, and within those classes, there are so many methods to read a file, to write in a file, and many things. So we directly call these methods, and that's it. You don't have to write code from scratch. System.out.println. To print something, we just simply use system.out.println. So there is already written what is the meaning of that println, how this compiler will know. Okay, in Java. So there is specifically like the meaning is defined already in that libraries. There's a print stream class. There we have some object of that class and all. System is a class, and with that, it's already written. There are so many classes and methods. We know we have used so many things. So that is library. Okay. So it's like set of predefined classes and methods and reusable data, reusable classes and methods. You can directly use them in your method whenever you need. You can directly use them. If you don't need, you skip. And when we download the JDK version, then it's automatically been downloaded with that. right? But yeah, there are third party libraries as well that you can externally download and use, but we haven't used those things. We just use inbuilt library, that is standard library in Java, JDK, right? So that is library. Framework, if you talk about those frameworks, Spring, React. Spring is basically, let's talk about Spring. In Java we have Spring. So that framework is, it's like a software that will help you to develop your applications. It's software. Libraries are not software. These are simple written like method, those classes and methods and all. These are not like, we can say these are software. But framework is a software that we can use to build your application efficiently, quickly. Like using those libraries, we can build your application run nowadays within minutes. You don't have to write nothing from scratch. You just directly use those frameworks and all, and you're sorted. Okay, so they provide those reusable software components that we can use and we can build our application, right? Like when you are going to deal with databases, so you have to connect with the database, your Java program with the database, right? And there are so many things when you are working on developing an application. Then security is also a concern, database connection, many things are there. So we have, I think you have heard about this Spring. Spring is a framework in Java. This Spring has already written modules to handle security, to handle database connection, to handle dependency injections. So you don't have to worry about these things. These things will be handled by that framework itself. You don't have to write like the code for database connection and security and all. So your life would be easy if you use these frameworks. So it's like pre-written. You can say softwares are there or modules are there. You can directly use them. And one thing we call library, from our code we call library, like we call from math square root method when we need. But when you are using framework, then that framework will call your code. It is the main difference. But that thing, the meaning of this thing, that framework will call your code, you get when we will discuss Spring, maybe in advanced Java course, not in this course. But if maybe someone of you are aware about Spring and has used that thing, they are maybe getting my thing, that in this case framework is going to call your code and like these things are working. But here we are calling inner code libraries. Okay, that is like a main difference between library and framework. But this collection framework is not those framework like we have Spring and all. Collection framework in JFC is like library like framework. Why I'm saying this is it's a library like framework, I'll tell you this thing also. See now, this thing we'll discuss right now. So framework, I guess the framework is clear to you. It's like with the real life, if you get this thing, then framework is like in university. You are going to a university or college, they are having their own like specific rules, their curriculum, their structure. They are like, they have some exams and grading system and everything. They provide you like from which kind of book you want to study and all. Okay, so everything is like defined. They have their own rules. Okay, you have to follow these things. But that's kind of framework. But without framework, it's like self study, self learning. So you have to find out what to study. You have to define your curriculum. You have to study the resource. You have to find out the resources from where to study and everything. There are no rules. You have to do yourself. So it's like without framework, you have to do everything from scratch. It's that kind of thing. But if you have framework, you don't have to do from scratch. You just focus on your study. That's it. Everything else is taken care by that framework or that architecture, right? So same also here with frameworks. If you use frameworks to develop your applications, maybe that web applications or mobile app or anything. So the developer just focus on the business logic. That's it. Everything else will be taken care by those frameworks. Now, what is that everything else, that also we'll see in context of Java collection framework. So that is, I guess, the meaning of framework is to somewhat clear to you. What is meaning of framework? So it's a pre-written, reusable software platform. It provides a foundation, or you can say a structure for developing applications efficiently. That is basically framework, right? Collection in Java. Now, what is collection in Java? See now, let me discuss this thing with example. Data is, we know that the main thing. So we can say that in a Java program, like we have like a Java program, then stack area, heap area, and something like this in CPU, in that memory. Okay, now obviously this is not CPU, like in main memory. Obviously, in main memory, we are having these things. While you're executing the program, that program should be loaded in the main memory, that we know. That is for sure. And if the program is working on some data, that data must be in the main memory. That is also for sure. And data is the crucial part. Without data, I mean, there's nothing. There's so many like those social media apps or these websites, and they handle the data, user data. If we create a simple project like library management system, that also handle the data, books, whatever they in the libraries, that books, users, and the data about that thing. So basically, you have to deal with data when you're writing any applications or project. That is the main motto. Data is crucial part. Without data, like there is nothing, right? And data can be like whether you can input from the keyboard or from a file. We can take the data to access the file, or from database also. There are so many things. From a remote machine also, you can take data. But data is the main thing. And when the program this is working on that data, so the program as well as the data must be in the obviously in main memory. That is for sure. You have to board that thing in the main memory at that time while executing the program. And the data may be, and it's not like that you always do sum of two numbers, so you need only two numbers. That's it. No, because when you are dealing with those applications, when you are developing applications or projects, then enterprise level project, then you have to deal large amount of data with, you have to deal with a large amount of data. So it's like a like list of data will be there. So that data can be like stack memory or heap memory. When you use arrays, then arrays are created in heap memory. So it depends when the data, actual data would be there. So data can be in the form of objects. It can be in the form of like simple integers, floats, strings, or objects kind of thing also. Many type of data can be there. It depends. Like we deal with many type of data. Okay. We need to deal with like many type of data. Sometimes simple integer data, sometimes with objects, sometimes with float data, double data. Many things are there, right? But we will deal with huge amount of data. That is for sure, right? Now, when you are dealing with a huge amount of data, then one thing is we have discussed arrays. Array we use. And see, when you are going to load that data in the main memory, then definitely you need to organize that data in the memory. That organization of the data in the memory is nothing but handled by data structure. So data structure is like basically the organization of the data in the main memory while executing the program, so that the operations, whatever operations can be performed on that data, that can be performed efficiently. Okay, that is data structure, nothing data structure, right? I hope you got this thing. Now we have discussed the very simplest, the basic data structure, that is arrays till now. But we cannot develop all the software or applications with simple the use of arrays. No, because there are so many limitations of arrays. First is the basic is arrays are of fixed size. We know, right? So it's not like that you can change the array size. Once you fix the size at the compile time, you cannot change it. Suppose I have created an array of size like suppose 1, 2, 3, 4, 5, 5. In Java, I have created something like this. Int my array is of size 5. And I want to store now. I need to store like 7. I need the size 7 or 10. What you do? Dynamically, array cannot increase its size. No. One thing is what you can do is you have to create a new array of size 10. You have to copy all the elements from this array to the new array. And then this ARR will, like you have to point that to this new array. Something like this will happen. Or there are many methods also, like we can copy the data with the in the arrays class we are having a method copy of, so you can copy the data. But the thing is you have to create a new array, that is for sure, having 0 to 9 index. Now maybe suppose after some time you need to store 20 data, so again you need to create a separate array and you have to copy this thing. So this is a headache, na? So arrays are of fixed size. That is one problem. But what if this kind of situation occur? We don't know at the starting only that we need this kind of data only, that's it. If you are sure that you need to store only 5 integer, that's it. So you can use array. You know the size of the data, but that's practically not possible. We don't know in advance the size of data sometimes, right? So that is one thing. These are not like extendable. Arrays are not extendable, right? And arrays can store like same kind of data, same type of data, homogeneous data. That is also one kind of drawback of arrays, we know. Okay. And that's why it's not really possible to develop all the type of applications or software with simple using arrays. We need some other data structure as well. Okay. Now, according to a requirement. So I've told you maybe a requirement is we need sometimes we don't know in advance the size of the data, one thing, right? Second thing, sometimes we need our data structure. Array is a data structure. So sometimes we need a data structure to extend automatically shrink. Like if I need, like now right now I need 5 integer to store, then I need 6, so automatically it will extend. And at some time, suppose I deleted this thing, so automatically it will shrink. That kind of thing we need sometimes. That may be a requirement. Okay. So that may be a second case, that may be like second case. Let me just write down this thing. It should automatically extend or shrink. Sometimes we need fast searching, because in array, one more drawback of array is searching is not fast. It take linear search, you have to apply, it take like order of n in terms of time complexity. Searching is not that much good. When you want to search an element in the array, you have to search one by one. Like suppose this is the array, I have 10, 5, 6, 7, 1. So I want to search for 1 is there or not. So you have to start from here. Is this 1? No. Is this? No. Is this? No. Is this? No. Yes. This is 1. So you have to go linearly, something like this. Okay, binary search is also there. That is having log n time, but it's not efficient. I want a quick searching in just constant time, order of 1. Sometimes I don't want order of log n. I want order of n, time complexity, right? So sometimes the requirement is we need fast searching. So we cannot go for arrays, right? Sometimes we need to store ordered data, and sometimes we need to store unordered data. Ordered, the data should be in ordered in a specific order. While inserting, if you have ordered the data in this, if you have inserted the data in this order, like first 10, then 7, then 8, then 1. So while fetching, order should be same. It cannot change. Sometimes unordered data. Ordering of the data doesn't matter. If you have inserted this kind of thing, you can access maybe at first this, something like this. The order doesn't matter. Sometimes we need to store duplicates. And sometimes we need to store unique element only. Sometimes I want a data structure that doesn't allow duplicates. Once you start to insert duplicate, it will give some exception or error kind of thing. Sometimes I want to insert a duplicate like here. That's are allowed. So that may be your requirement according to sometimes according to the project need. Right? Sometimes maybe you need to store a data in key value pair, key and value in this pair. It's kind of like hash table kind of thing. Okay. So the searching in this case is very fast. In order of 1, you can search anything. If you have the key, according to that, you can fetch the value. So the data is having a key as well as the value according to that. Like key value, like I have students, roll number of the student and name of the student. So key, maybe I can make roll number, and value is like the name of the student. So a pair of data. At the same place, a pair of data I want to store. So like here, not 10, I want to store here the roll number as well as the name. Roll number as well as the name. Roll number as well as the name. Something like this. So this can be possible with hash tables and this thing. So maybe the requirement is something like this. So Java basically, so we cannot simply use arrays to fulfill all these things, all the requirements and the operations we want to perform on the data. So Java gives you many like data structures, or we can say collections. Collections is nothing but, in simple terms, if I say, then it's a data structure, because in collection you get the list, map, queues, stack, vector. These are under collection. So these are, we know, the data structure. Queues, stack, map, trees. These are data structure. So collections are nothing but, it's like data structure. So Java provides you many collections, many data structures according to the requirement and the operation you want to perform on that data according to that. Right? So that's why it's known as like, and collection, in collection, like we are having a, you can say, collection framework. It's like, you can define it as having many interfaces. So what we are having here, interfaces, we are having implementation of these interfaces. Implementation means the classes which are going to implement whatever we are going to implement these interfaces. So implementations. And we are having some algorithmic classes. Algorithmic classes means, now we know that while searching data from the array, we have methods like linear search. One more is binary search. So you have to write down the code for linear search, binary search if you want to search something. But Java collections provide you automatically inbuilt for these things. Linear search, for binary search, you simply call that method and that's it. You don't have to write down the logic of linear search or binary search. No. It's just simple. In one line only you can do binary search on the array. That's it. So it's already taken care by the collection framework. It's already written there. You can directly use them. You have to just focus, the developer just have to focus on the business logic. That's it. Don't have to write the complete thing from the scratch. So it's really like helpful. And this collection frameworks were added in Java 1.2. Before that, they have to use simple, obviously, everything from scratch. Before that, yeah, we were having vectors in Java, we are having stack in Java, we are having hash tables in Java. But it's not like that. If you have to apply this linear search or binary search, you have to completely apply the logic, the loops and all, everything. So after that, in 1.2, they added, with under the name of Java collection framework, everything, these kind of things. So that you don't have to write down everything from scratch and you just focus on your logic, business logic, what you need to do, not these things. You can directly call from Java collection framework these things. If you want to, I want to need a data structure, like I want to use stack or queue. So you don't need to implement queue and stack, because obviously to implement stack and queue you need either arrays or linked list. You have to complete write down the logic to create a queue kind of thing or stack kind of thing, because these are stack, queue, these are logical data structures. Arrays are, or linked list are, physical data structure. Physical means actually data is stored in the memory. Arrays in arrays form or linked list form. But we know that stack is last in, first out. Queue is first in, first out, FIFO. First you enter whatever the data. First, suppose you enter 10, insert 10. So this 10 would be out from the queue. This is like a principle kind of thing. I want this kind of behavior. I want to implement this kind of behavior. I want to implement this kind of behavior, LIFO, last in, first out. But you can implement this kind of behavior using physical data structures, either arrays or linked list only. Directly, there is no way that in memory data is stored in LIFO structure or stack kind of thing or queue kind of thing. No. So these are logical data structures, right? So first you have to write down some code to implement stack and queue, maybe using arrays or linked list. Prior to this 1.2, prior introducing of this Java collection framework. But once they introduce this thing, you directly use, there are already there the classes and all, you directly use stack and queues and you don't have to implement. You don't have to write the method to implement these things. I'll show you practically how these things are happening. This is just an introductory video. Why we need it, this collection framework, that just I'm discussing that thing. Why? Just to save the time of the developers. They have inbuilt, they have already written these things. You directly use these things. So in that collection framework, you need interfaces, implementation classes of these things, algorithmic classes. How to use these things, what are interfaces, what is the implementation, what are these classes. We'll see one by one practically, don't worry. There are so many interfaces. And we know that interface is what? It's like a Standard in interface, we are having generally all the abstract kind of method. There is no implementation of those methods. It just define the rules and the methods that this whatever class is going to implement that interface, that class must have to implement this method. That kind of thing. It's kind of rule for all the classes who are going to implement that method. So there are they have set some standard rules to follow by every class. Like in university, we are having rules. Every student has to follow. If you want to take admission in that university, or if you have taken the admission in that university, you have to follow the rules. Same. If the classes are going to implement these interfaces, whatever we have here, like we have map, set, queue, list, these are interfaces. Array list is a class, linked list is a class. These are implementing list interface. So both the classes will follow the same standard rules of the that interface. Okay. So it's like that's why we are saying it like a framework, but it's more of library like framework. In library also there are pre-written classes methods. Here also we have those pre-written classes methods and all. So you can directly whenever you need in the code, you can just directly call these things. It's library like framework. Don't get confused that this is the exact same framework as you have Spring framework. No, this is not exact the same framework, right? So we can say that this Java collection framework is also a set of interfaces and classes that are helpful in managing, storing, and processing the data efficiently. And here you get implementation of many data structures like list, stack, queues, maps, these things. Right. Now, obviously, here we are having already written the, you can say, everything, the generic classes as well for searching and sorting. So you can directly call these things. Everything is built in. Built in data structures are available, stack, queue. So you don't have to write code. You don't have to write code to implement these data structures. You can directly access that code from the Java collection framework. Okay. Now, let me, I guess the need of Java collection framework is clear to you. Why we need this thing. Now, let me show you the hierarchy of JFC, Java collection framework. What are the interfaces and classes in this framework? So this is basically hierarchy of Java collection framework. Okay, sorry, it's like Java collection framework, right? So here I've told you we are having it's a set of classes and interfaces that basically are helpful in storing and processing and organizing the you can say the data efficiently. Okay. Now at first, whatever is there in this oval shape, these are interfaces, and in this rectangle we are having classes, and this dotted line means it means implements, and this solid line means extends, because we have discussed inheritance. So I hope you are aware about the meaning of interface, class, implements, interface, extend. So first is iterable interface. That's not that much kind of tough. It is having only one method, iterable. But the thing is, we'll see more about this later. The main thing in Java collection framework is collection. This is an interface. This is the main root of all the like these classes and interfaces, right? Collection interface. It is having many methods. And if you got what are the methods here, because obviously these are the interfaces and classes below collection. So they are going to extend or implement ultimately the collection, you can say interface. So if you are aware about whatever the methods here, you are almost done with all the methods here we are having in these classes and interfaces. This is the main thing. We will see later one by one in detail about each and everything, but this is just the introductory part. So now we are having under this three interfaces: list, queue, and set. At first, let's see list. This is an interface, as the name suggests, list. So collection is also it's like a you can say group of objects, which is under a single unit group of objects. In list, we are having this is you can say ordered ordered group of data. Ordered like we are having this data 10, 5, 4, 3, 2, maybe 10 again. So we are having here indexing. if you have indexing on the data, that means that is ordered data, means the ordering matters. The 10 is at 0th index, so it matters. This 5 is at 1 index, so it matters. That's why indexing is there. So ordering of the data matters here. So list is like, you can say, ordered. So ordered collection of the data. But here see, there are duplicates also. 10 and 10 duplicates are allowed. So these are list. This is the interface. Now this interface is implemented by these classes: ArrayList, LinkedList, then vector and stack. These are, you can say, these are legacy implementation. Legacy implementation means these vector, stack, these, and this hash. Sorry, next we have map also. So this hash table. These are three are legacy implementation. These were before introducing of the Java collection framework. Means from starting of Java, these were there: vector, stack, hash table. Okay. In 1.2, I've told you this JFC, Java collection framework, JCF, was introduced. So that's why they have added this also there. So these are known as legacy implementation are still there. Right. Now, these are the extra things: array list, linked list, vector, and this vector is a class, stack is a class which is going to extend this vector. We will see each and every class and interface in detail, don't worry. It is just the overview so that you have the idea. In just have the picture of these things in your mind, and you remember these are the interfaces in Java collection framework. These are the classes and all. Which class is going to implement which interface and all. Next, we have queue. So here under queue, we are having one more interface, that is DQ. Queue is what we know. The principle of queue is first in, first out, FIFO. It works on FIFO principle, first in, first out. Right? Now, okay, this is not something like you can say class or and this queue, this interface is implemented by priority queue. Priority queue is a class. So here priority is given to that element, not the insertion, but the priority of the element matters. Priority of the, you can say that obviously that item matters. Now here we have one more interface, DQ, which is implementing queue, and this array DQ is also a class which is implementing DQ interface. This DQ is extending queue, because once a interface extend another interface, not implement. One interface extends another interface. Class implements interface. We write this thing. Right? Now we have set. Set. See, in list we are having duplicate data. But sometimes I told you the requirement is no duplication of the data is allowed. So in that case, we have set. In set, duplication of the data is not allowed. But this is unordered. The order is also not there. So there are no indexing kind of thing. This is not there. So unordered collection of data, but unique elements. Duplicacy is not allowed in set. Okay. Now set are also having this interface is implemented by these classes: hash set, linked hash set. Now one more interface we have: sorted set. We know that sometimes sorting of the data is also allowed. So one requirement you can also add: sometimes we need sorting of the data, sorted data. Sometimes we need unsorted data. So that once you insert the data, that should be automatically sorted. The list or that thing should be automatically sorted. So that kind of thing is handled by this sorted set interface, and TreeSet is a class which is going to implement this sorted set interface. Okay. Now, there is one more interface, map, but map is not under collection. But map is also a part of the framework. It's not under collection framework, but it is a part of the framework, Java collection framework. Map. This is the interface. Now the classes which are going to implement this map is hash map, linked hash map, hash table. This is legacy implementation. This was already there in Java previous version as well, from Java starting of the Java. Here also we are having sorted map, one more interface, and tree map is a class which is implementing this sorted map. So map is like we are storing the data in the form of key value pair, that is handled by this thing, by hash map and hash table. And these are really quick in searching. So these kind of things, these data structures, hash map, these things are ArrayList. These are really important once you are going to solve the problems on lead code or maybe in kind of placement kind of thing. So you must aware about these things. We will see one by one about these things later. So I guess the hierarchy of this Java collection framework is clear to you. What are the classes? What are the interfaces in this Java collection framework? So see here, collection is what? It's a group of objects represented as a single unit. So you can think it as a container that stores the data. It's a collection. Collection framework is what? It's a unified architecture providing interfaces, classes, and algorithms. It standardizes how we work with groups of objects. It standardizes how we work with the group of objects. Like in list interface, there are some standard methods and all. So the classes which are implementing the interface, ArrayList, LinkedList, stack, then vectors. These are basically I'm going to follow those rules or have to implement those methods. So we have standardized those things with the help of interfaces, right? So it reduces the programming effort, increase the performance, and promotes software reuse through consistent APIs. That we know we can easily tell the advantages of using this collections or collection framework, right? Now, limitations of array we have discussed because in the very first you are having the basic data structure array. So these are some limitations: fixed size, same kind of element, no built-in methods are there in arrays. There is no like utility methods we can use, and obviously wastage of memory. Now, why we need collection framework? Definitely for flexibility. Collections can grow, shrink, and adapt to data needs automatically during runtime, like ArrayList. ArrayList is one that you can say data structure. There, you do no need to specify the size at first. In arrays, you need to specify the size while creating the array, but in advance, we don't know the size of the data. You can use ArrayList. You don't need to specify the size, and it will automatically grow and shrink according to the data, according to the requirement. So that's why this is the beauty, flexibility. Performance, definitely, performance would be more, right? Now, consistency, it provides the common interfaces. The list is a common interface for array list, linked list, stack, and all. Set is a common interface for all the like classes, or there we have below that set. Okay. In collection also we have a collection is like a common interface for all the other classes and interfaces. Okay. So now it provides a common interfaces ensure that predictable behavior across different collection type, different types of collections. Right. So we have standardized that thing. Productivity, obviously, productivity would be more rich APIs with ready to use methods, save development time, definitely, and reduce the errors. Okay, we can directly use those built in kind of things. So, less time you have to devote to write that thing from scratch. You just focus on your business logic and less, you can say, probability of getting errors, right? Now, collection framework hierarchy also we have seen. First, we have iterable interface. So this is the root interface that ensures iteration over elements. It is having only one method that I'll show you that thing also. We'll discuss this thing in detail. Don't worry. Now, collection. It is the basic container for a group of objects and it extends iterable. Then we have list, set, and queues we have seen. Then map. This stores the key value pair. It's not a like true collection because it's not a part of collection framework. It doesn't extend collection. But yeah, it's a part of framework. It's a part of Java, you can say framework. It's not under that collection uh, interface, right? So this is all about like they have seen like list interfaces. I have shown you, I've told you the list is like ordered collection of data. Element can be accessed by position and implementation, fast access, slow modification. Linked list means fast modification and slower access in linked list. We'll see array list, linked list, then you will get the advantage and drawback of these things. Don't worry. Okay. These are some common operations and these are some use cases. When you need a random access by index, you use these things because this is ordered collection. Ordered collection means having indexing, right? Set means unique elements are there. If you need unique elements in your data structure, if you know that kind of data structure, go for state. But this is unordered. There are no indexing kind of thing here, like hash set we can implement, but fast operation that is for sure. Or common operations are same like add, remove. These are common operation of all the interfaces, right? Q and DQ. Q is like FIFO principle, elements added at the end, removed from the front. DQ, it's double-ended queue. Double-ended queue. It allows insertion and removal from the both the ends. In Q, one end is for insertion, one end is for deletion, right? From the rear, you can insert. From the front, you can delete. DQ, both the ends you can use for insertion and deletion. That is DQ. Priority queue elements are ordered by the priority, not by the insertion. It is useful for scheduling kind of thing. We'll see these things. Map interface, store the value in the key value storage, store the data in this thing. Each element has a unique key and associated value with it. Hash map, tree map, linked hash map, they are going to implement this interface, and same common operations we are having, almost same, not same, almost. We are having here put, get, remove, contain key. There we are having add, remove, these kind of things. Okay, so these are used, this kind of thing is used in dictionary. I guess if you are aware about Python language, then there we have dictionary. Dictionaries are used to store data in key value pair. So use cases of this thing: dictionaries, lookups, and caches. So in dictionary, like you can go for a regular dictionary as well. There we have the key value pair. Data is something like this. Okay, so you can just go and search for a dictionary if you have, and you can see there the data is stored in key. There is a key associated with that key. There is a value of that data. Okay, now that's about this thing. In the next lecture, we will see now in detail about first collection interface. At the very first, we are having collection. So we'll see something about iterable, and then we'll see collection interface. One by one, we will see everything. So that's it for this lecture. I will see you in the next lecture. Till then, bye bye. Take care.